This is a review for our Systems of Equations test that will be on Friday, April 13th. The first problem in our review is to solve by graphing. In order to solve by graphing, we want our equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So let's start with our first equation. 2x minus y equals 3. To get it into slope-intercept form, we should subtract 2x off both sides of the equation, leaving us with negative y equals negative 2x plus 3. And then to get y by itself, we'll divide everything by negative 1, leaving us with y equals 2x minus 3. Our y-intercept is negative 3, so we'll start at negative 3. Our slope is 2, so we'll go up 2 and to the right 1. Up to right 1 every time, making our various points. Or we can go down to left 1 and then connect those with a line. Obviously, your line will be straighter than mine. Then for the other equation, x plus 3y equals negative 12. This one should be positive 12. That is a typo. We'll start by subtracting x off both sides. So we get 3y equals negative x plus 12. And then we'll divide everything by 3 to get y by itself, leaving us with y equals negative 1/3 x plus 4. We'll start at our y-intercept of 4, go down 1, right 3, and look, we found our solution. But we'll keep graphing the line because on your quiz or test, there will be points for actually graphing the lines. And then we will connect those. And our solution is where those two cross, which is the point 3, 3. Remember, it's a good idea to check this, and I have done that on my own time. So that would be a good idea when you're taking your test. Next problem on your review says to participate in a school trip, Kim has to earn $85 in 1 week. Kim could earn $8 per hour by babysitting and $15 per hour for yard work. Her parents will only let her work 8 hours per week. So we need two equations to represent this situation. First, we have $8 an hour for babysitting and $15 an hour for yard work to equal her $85. There's our first equation. Second one is just her total hours, x plus y, babysitting plus yard work equals 8 total hours. So in this case, x will represent her hours babysitting, and y will represent her hours of yard work. Sorry for that W. All right, explain what each equation means. So the first equation, 8x plus 15y, that's going to be her money earned. The second equation is her hours worked. The next piece of this says to solve using substitution. Remember, the first step in substitution is to solve one equation for one variable. Well, in the equation x plus y equals 8, both of those variables have a coefficient of 1, making them easy to solve for. It doesn't matter which one we solve for, so I'm going to solve for y. So I subtract x off both sides, and I get y equals negative x plus 8. The next step for substitution is to plug that into the other equation. Oh my. Sorry, not sure what happened there. That's 8x plus 15y equals 85. So replacing y. So 8x plus 15, instead of y, we're going to write negative x plus 8 equals 85. Now we're going to solve for x. First, we should distribute the 15. So negative 15x plus 120 equals 85. Now we'll combine our like terms. 8x minus 15x is negative 7x plus 120 equals 85. We'll subtract the 120 off of each side, leaving us with negative 7x equals negative 35. Divide by negative 7, and x equals 5. Now we have to figure out what y is. So we're going to take that value and plug it into this equation we had over here. So y equals negative, plug in our 5, plus 8. We replace our x with 5. That means y equals 3. Finally, we should write our solution as a coordinate point, 5, 3. It would always be a good idea to check this by plugging it into our original two equations. Then explain what our solution means. I'm just going to do this out loud, so I hope you're listening. This solution means that she needs to work 5 hours of babysitting and 3 hours of yard work in order to earn $85 and only work 8 hours. The next problem says to solve using elimination. Remember, we like elimination when all variables have coefficients. None of these line up, so you get to choose what you want to eliminate. I'm going to eliminate the x's because one's positive and one's a negative. So I need my -5 and my 8 have the same coefficient. Well, I know that the common coefficient would be 40. So I'm going to multiply the top equation by 8 and the bottom one by 5. That turns the top equation into -40x, multiply -6y by 8 makes -48y equals 28 times, which is 224. In the second equation, I'm going to multiply by 5. 8x times 5 gives me 40x. 10y times 5 gives me the -50y. And 14 times 5 is 70. Now to solve this, we can add the two equations together since the 40 and -40 will cancel each other. That leaves me with -98y equals 294. Now to solve for y, we're going to divide both sides by -98. This will give me a solution of y equals -3. Now we're going to plug that into either original equation. I'm going to use -5x minus 6y, so replace my y with -3, equals 28. So I'll multiply, so -5x plus 18 equals 28. Subtract 18. -5x equals 10. Divide by -5. And x equals -2. That means our final solution is -2, -3. Now you get to solve using either method. In this case, I have 6x plus y equals -6 and 4x plus 3y equals 10. I'm going to solve using substitution because I noticed that I can easily solve for the y in the first equation. So to solve for y, I'm going to subtract 6x off of both sides. So I end up with y equals -6x minus 6. I'll plug that into the other equation for y. So I have 4x plus 3 times -6x minus 6 equals 10. Distribute that 3, so I get 4x minus 18x minus 18 equals 10. Combine my terms, I have -14x minus 18 equals 10. Scroll down a little for us here, add 18 to both sides. And -14x equals 28. Divide by -14. We find that x equals -2. Now we'll plug that in to this equation we solved for y. So y equals -6. Replace our x with -2 minus 6. So y equals +12 minus 6. And y equals 6, making our final answer -2, comma 6. For problem 5, I see that my x's and my y's line up, and I could easily make my 5x into a 15x or my y into a 3y, so I'm going to use elimination. I'm going to multiply that top equation by 3. So I get 15x plus 3y equals -3, and at the bottom equation I'm leaving the same. So 15x plus 3y equals -3. Since I noticed the 15x and 15x are the same, I'm going to subtract my two equations. 15x minus 15x is 0. 3y minus 3y is 0. -3 minus -3 is 0. If I get something like 0 equals 0, I have infinite solutions. And our last problem, 16x minus 16y equals -19, and 12x minus 12y equals -12. All my variables have coefficients, so I'm going to use elimination. Between 16x and 12x, I know that the least common multiple is 48. So I'm going to multiply my top equation by 3 and my bottom equation by 4. 16x times 3 makes 48x, minus 16y times 3 makes 48y, equals negative 19 times 3, which is negative 57. For the bottom equation, 12x times 4 makes 48x, minus 12y times 4 makes 48y, equals negative 12 times 4 is negative 48. Since I noticed that my x's have the same sign, they're both positives, I'm going to subtract my two equations. 48x minus 48x is 0. Negative 48y minus negative 48y is 0. Negative 57 minus negative 48 is negative 9. Well, 0 doesn't equal negative 9. That means there is no solution.